Hello, everyone. Thanks for joining. Today, we'll continue practicing with the convolutions, the continuous time and the discrete time. Continuing from the same examples that I shared with you in the last session. But first, let me share my screen. Okay. Just a reminder, remember the convolutions in continuous time and discrete time. Discrete time convolutions is just a sum. Let's say yn will be summation over k from minus infinity to plus infinity, x k as they say, this is the input times the impulse response of the system, but flipped and shifted, flipped or time reversed and shifted by n, just in time domain. And similarly, this is discrete time. And similarly, if we have continuous time signals, this will be a summation will be integral, and we will have this formula, integration from minus infinity to plus infinity of x tau ht minus tau t tau. So this is the input evaluated at tau, and this is the impulse response time reversed and shifted, time reversal and shift. Okay, with that being said, let's practice with some examples. I'll first start with a continuous time convolution, and then I'll revisit one of the examples that we have solved in the previous session, and I will show you a simple and new method to solve those convolutions. So first, let's start with this example, continuous time convolution. Let's say we have an input signal given by x of t equals e minus t times ut minus u t minus 1. And the impulse response of the system is 2 ut minus ut plus 1 minus ut minus 1. Okay. Let's try to sketch those two signals just to have an idea about the signals and the impulse response of the system. So for xt is a decaying exponential function, but bounded or limited only to this region, to this rectangle between ut minus 1. If you remember, ut minus 1 is just a rectangle between 0 and 1. So let me just sketch the ut minus 1. This time, ut will be 1 starting from t equals 0 until infinity. ut minus 1 will be 1 starting from 1 till infinity. but with a negative sign, so it will be on the negative side here. So it will cancel with ut, and what's remaining is just 1, 1. So this is 1, this 1, only this rectangle. Okay. So if we multiply this by the exponential, we'll get the following. Um, this time and this xt, which is exponential minus t ut minus ut minus 1. Exponential at 0 would be 1 and will start decaying. Something like this. Approximately. So this is 1 and this is 1. This is 1. And this part will be 0 because we multiply this exponential by this rectangle. So this will disappear. This is 0 here. So the function is only this region, or the signal, the input signal is just this part. Now for the ht is 2 ut minus ut plus 1 minus ut minus 1. Let's plot each of these individual step functions, and then we'll find the ht, the impulse response. T is ht. Ht is 2 ut. Let me use a different color. 2 ut. So at 0, this will be 2, and then will remain 2 until infinity, until t goes to infinity. So this is ut. So this is 2 ut. And then we have minus ut plus 1, a different color. Minus ut plus 1. So ut plus 1 starts at t equals minus 1, say here, minus 1, and takes value 1 and then remains 1 until t approaches infinity. But here we have minus 1, so it would be like this. Okay. Then the last portion is minus ut minus 1. It's similar to what we had in xt. It starts at 1 till infinity, but it's flipped. So this one will be starting from 1. Let me use a different color. Starting from 1 will become minus 1 until infinity. So this is minus ut minus 1. And this is minus ut plus 1. If we add all of these together, this part will remain minus 1, And then this 2 will cancel with those two, because here we have -1 and -1, so -2 in this part. So this part will cancel, and what's remaining is just this. And this is the impulse response of the of the system. Now, to do the convolution, sorry, we are interested to calculate y, which is the convolution between xt and ht. And this is defined as the integration minus infinity plus infinity x tau times h t minus tau beta. Now looking at xt, it can only take values, it's only non-zero between 0 and 1. So clearly the integration limits will be just from 0 to 1. And then we need to find the ranges for t and do the integration over those ranges. So this will be the integral from 0 to 1 only of x tau h t minus tau d tau. And here again, what we are doing to the impulse response is time reversal, time shift. So we do a time reversal, we reverse the signal, and then we start shifting it from minus infinity to plus infinity. Now, if we shift the impulse response, or sorry, if we do the time reversal of the impulse response first, this square will be flipped to this side. So let me plot here. And let's now change the name of the time variable from t to tau. It doesn't matter. It's just the name of the variable. So, and now I'm plotting h minus tau. And this square, it's plus, here it's -1, and this one is -1 as well. If we do a time reversal on this one, it will be like this. -1, and this one is +1. And if we compare this one by this one, we can see that there's an overlap between those two. This one's from 0 to 1, and this one's from 0 to 1. So if we shift one by if we shift this one by t larger than 2, so it will move to the right by more than 2, we will be completely outside this region. So it will be somewhere like this here. And there will be no overlap between those two signals, and then the integral will be 0 when t is larger than 2. Right? And when t is between 1 and 2, we will have some partial overlapping. Let's say something like this. And this will be, yeah, we'll have some just partial overlapping between those two signals. And the integration will be just over this portion of the signal, which is from t minus 1 to 1. T minus 1 to 1. T minus 1 is because we have shifted this one um, by a t, which is between 1 and 2. And so on. If we have, if the time shift is between 0 and 1, we'll be overlapping like this. Sorry. I think we've made a mistake there. Yeah, let's get back to the definition. The definition of the impulse response is T ut minus ut plus 1 minus ut minus 1. What we have plotted here is 2ut minus ut plus 1 minus ut, because it started from here. It should start from this area. So let me correct this one. So this red one minus minus ut plus 1 remains the same. But minus ut minus 1 start from plus 1 from here. We use and it will be minus 1 like this. Now, if we add all of these signals together, here we have just this minus ut plus 1 alone will not cancel with anything. So we'll have minus 1 here. And then at this point, plus 2 minus 1 is plus 1. And then in this region after 1, we have plus 2 minus 1 minus 1. So it will cancel. So we'll have something like this. Minus 1 here, plus 1 here, and then 0. So the impulse response will look like this. Not just this square, those both squares. And if we do time reversal on this one, it will look like this. Yeah. So this ht, this is h minus tau or minus t, the same, just time reversed. This part shift to this side, and this side shift to this side. So this is the impulse response time reversed. Now everything here is correct. Nothing have changed, and the range of the integration is 0 to 1 because xt is from 0 to 1, which is okay, which is correct. Now let me find the time shifts or the ranges for t again. If we shift this one by larger than 2, t, let's say t is larger than 2, it will be like this. This 2. So we'll have something like this. And there'll be no overlapping, and the integration will be 0 in this case, when t is larger than 2. Now, if t is between 1 and 2, if t is between 1 and 2, larger than 1, less than 2, we'll have So this one, we will have a partial overlapping with this part. So we'll have something like this. This will be ht, h minus tau shifted by t, while t is between 1 and 2. So we'll have overlapping between this in this part only. So after shifting by t, which is between 1 and 2, this will be t, t plus 1, plus 1, and t plus 2. And the integration between will be just between, sorry, this was 0, so this point was 0. So if we shift to the right by t, so this will be t, this will be t minus 1, and this will be t plus 1. And the integration will be just between t minus 1 till 1. This is the overlapping area. And so on. If t is between 0 and 1, if t is between 0 and 1, between 0 and 1, so we will have overlapping with this part, 0 to t, and then to 1. So it will look like this. This t, t plus 1, t minus 1. Okay, and the integral, the overlapping will be in this region and in this region. So this one is from 0 to t multiplied by plus 1. The integrand is multiplied by plus 1, and then from t to 1 is multiplied by minus 1, because this part is negative. Let's write all of these integrals together. So yt will be, we'll have multiple different regions. The first one is when t is larger than 2, and there will be no overlapping between xt and the shifted and reversed impulse response. When t is between 1 and 2, as we have seen, the overlapping will be between t minus 1 and 1. So the integral will be t minus 1 to 1 exponential minus tau d tau, and it has a positive sign here because this part will be overlapping, and we multiply by plus 1. And then the third interval is when t is between 0 and 1. So t is larger than 0, less than 1. And in this case, we will have, as we have seen, we will have two parts. One of them overlapping here with the positive side, and the other one overlapping here with the negative side. So we'll have two integrals. One of them is from 0 to t plus exponential minus tau d tau, plus the other integral is from t to 1 negative exponential minus tau d tau. Then the next interval is when t is larger than minus 1. and less than 0. In this case, only this portion of the impulse response will overlap with the signal. So we'll have integration from 0 to t plus 1. The integration will be from 0, t plus 1, negative exponential minus tau d tau. Negative because this part is negative 1. And then finally, when t is less than minus 1, when t is less than minus 1, we'll have 0. If we have shifted this impulse response by more than minus 1, or I mean less than minus 1, so more than 1 to the left, there will be no overlapping. The impulse response will be somewhere here, and we will have no overlapping between the two. So the integral will be on this interval will be 0. And if we calculate those integrals, so we'll have 0 over the first interval, t larger than 2, and then integral of exponential minus 2 from t minus 1 to 1 is minus exponential minus tau. Let me write it in a better way. Minus exponential minus tau when tau is between t minus 1 to 1. Which is minus e minus 1 plus e 1 minus t. This is when t is between 1 and 2. The next interval, we have two integrals. From 0 to t exponential minus tau, so minus exponential minus tau between 0 and t, plus minus exponential minus tau, so minus will become positive, and the integral is will be minus exponential minus tau between t and 1, which is this part is minus exponential minus t plus 1. So minus exponential minus t plus 1 plus this part will be exponential minus 1 minus exponential minus t minus t, which is 1 plus exponential minus 1, those are just constants, minus 2 exponential minus t. And this is when t is between 0 and 1. The next interval is between when t is between minus 1 and 0, and we have this integral. So minus exponential minus 2. If we take the integral, this minus will be multiplied by this one, so we'll have plus exponential minus 2 between 0 and t plus 1. 0 t plus 1, which is exponential minus t plus 1 minus 1. And this is when t is between minus 1 and 0. Minus 1 and 0. And then finally, the last interval with no overlapping when t is less than minus 1. So let me highlight those intervals. So in this example, we started shifting from the right to the left. It doesn't matter. The only point that you should consider is to shift the impulse response over the whole range of t. So from minus infinity to plus infinity, or from plus infinity to minus infinity. In this case, we started from plus infinity. So t is larger than 2. We don't have any overlap. And then when t is between 1 and 2, we have some overlapping, and so on. We have those 5 intervals. If I want to plot this yt, it will look like this. It's not easy to plot accurately, but so this is yt, this is t. When t is less than minus 1, let me plot a different color. When t is less than minus 1, it will be 0. When t is larger than 2, it will be 0. So plus 1, plus 1, plus 2. When larger than 2, it will be 0. And then from minus 1 to 0 is just a decaying exponential but shifted by 1. So when t equals minus 1, this will become 1, minus 1, 0. So it starts from uh, minus 1, starts from 0, and at t equals minus 1, we will have a decaying um, exponential, something like this, until from minus 1 to 0, until 0, something like this. And then from 0 to 1, from 0 to 1, we have 1 plus e exponential minus 1 minus 2 exponential minus t. So minus 2 exponential minus t. When t equals 0, this will be minus 2. Plus 1, it will be minus 1 plus small some constant. So we start from this point, and negative exponential minus t, so it's a growing exponential. So it looks like something like this until 1, and then from 1 to 2, from 1 to 2 we have also some extent constant, and then a decaying exponential. Will look like this. Yeah. And if you calculate those constants, you'll find that this point is around 0.6, and this point is also around a little bit larger than 0.6.